You okay back there? So we are going to focus mainly today on solving trig equations. We actually did a little bit of this yesterday as well. So if you look at, this kind of thing, this whole page, these were trig equations. Because essentially what we're doing is using a trig ratio to determine an unknown angle. Okay. So we're going to start with sort of the basic stuff, and then we are also going to look at second degree trig equations, which are also going to incorporate some factoring as well. Okay, so we're going to start by solving some trig equations over a restricted domain, which means you're going to have some sort of restriction like this in the question. Okay. We'll also talk about the general solution and what that means and how to write it, because you could be asked for both, or you may just be asked for the solutions over a restricted domain, or you might be asked for the solution, the general solution, in which case you don't worry too much about, you don't have a domain. Domain is that the angle can be anything. Hi. Yeah. Do you want to just stick it here?
Yeah. Sorry to interrupt.
All good. All right, so most of these questions we're going to solve for exact values. So we're going to be thinking about all of those angles on the unit circle that relate to the special triangles, or using just the special triangles and cast to determine the solution. Okay, so for example, solve the equation sine theta equals 1/2. Over this domain, 0 is less than or equal to theta less than or equal to 360. Okay, so if sine theta equals 1/2, then the reference angle is the sine inverse of 1/2. And if this is our special triangle, the angle that has a sine ratio of 30 degrees is, of 1/2 is 30 degrees. Yeah.
Sorry, do you have to use the sine inverse, or like could you
No.
show that? Or
No, you can just use, you can just say theta equals 30 degrees, right? But the reference angle, yeah, you do not need to show this step, okay? And in fact, a lot of times it's not going to help you anyway, because especially if you're in radians, you will get the decimal approximation for that angle measurement, but most measures in radians are given in terms of pi. And so you want that exact value anyway, okay? All right, so our reference angle is 30 degrees. Sine is positive here and here, okay? So one solution over this domain is that theta equals 30 degrees. The other solution, if this is 30, then this is 150. Okay. If we were to solve this over a new domain from 0 to 720, we're adding another rotation. Essentially, all we're going to do is take, though it's going to include these two angles because this is within the domain, and then to each of those angles, we would add 360 degrees. So 30 plus 360 is 390, so that's another solution. And then 150 degrees plus 360 degrees is 510. Okay, now the general solution is usually given by using the principal angle and then plus or minus 360 degrees times n. So we can add multiples of 360 or subtract, or if it's in radians, you'd add multiples of 2 pi. So in this case, because we're solving in degrees, now keep in mind, these two are different answers. So there are going to be two different general solutions. One of them is all the angles that are coterminal to 30 degrees. So 30 degrees plus or minus 360 degrees times n. where n is an element of the natural numbers. And then the other one is all angles that are coterminal to 150. Okay. Now, if this was in radians, you would just change the 360 to 2 pi. That's the only difference. Okay? All right, so this first example was a very, very basic trig equation. What we're going to look at next is a trig equation where we actually may have to do a little bit of work first to be able to get the trig ratio, right? So here we have 3 cosine theta minus 1 equals cosine theta plus 1. Essentially, if we collect all of our cosine thetas on one side and all of our numbers on the other, then we can start to work towards getting a trig ratio. Okay, so what I'm it's like solving a linear equation. I'm going to subtract cosine of theta from this side so that I have, this is now 2 cosine theta minus 1 equals 1. And then I'll add 1 to both sides. And what I get is 2 cosine theta equals 2. Okay, so essentially what you want to do is isolate the trig ratio. So if 2 cosine theta equals 2, if we divide both sides by 2, then we will get cosine of theta equals 1. Okay, so we're looking for the angle for which the cosine of that angle is equal to 1. Do you guys know what that is? It's 0, yeah. And with these ones where you're looking at angles that are going to be on the axes, probably the easiest thing to do is to think in terms of the fact that each of these coordinate points is cosine theta sine theta. So which angle has an x coordinate of 1, because that's the cosine of that angle, it's this one over here. Whoops, sorry. 1, 0. Okay, and that angle is 0 radians. Okay, so that's one solution. Now to 0 solutions, to think about the domain, we can add or subtract 2 pi. So if I subtract 2 pi from 0, I'm going to get negative 2 pi. And this end is inclusive, so we can include that value. And then we can also add 2 pi to 0, and that will give us 2 pi. Okay, so those would be the 3 solutions within that domain from negative 2 pi to pi inclusive. Okay, now these trig equations, we notoriously give you a domain sometimes where one end is inclusive and the other end is not. So you have to just watch out for that and pay extra attention to those inequalities to see whether they're inclusive or not. Because if this just went from negative 2 pi is less than theta, which is less than 2 pi, then we wouldn't include this one. Okay? All right, let's look at another one. We've got 4 secant x plus 8 equals 0, and here 0 is less than or equal to x less than or equal to 360 degrees. Okay, so where would you start here? Isolate secant x, yes. So I'm going to subtract 8 from both sides, and I will get 4 secant x equals negative 8. Okay, and then what would you do next? Divide by 4 rather. Right, so we get secant x equals negative 2. Okay, now what? Yeah, right? So now we want to start thinking about writing this in terms of cosine. So the secant of an angle and the cosine of an angle, those trig ratios will be reciprocals of one another. So if secant x is negative 2, cosine x equals negative 1/2. Okay, and so from this trig ratio, the reference angle is the angle that has a cosine of positive 1/2. So if we go back to this picture over here, the cosine of 60 is 1/2. So in radians, 60 degrees is pi by 3 radians. So the reference angle is pi by 3. Okay. Now remember, that's not our answer in this case. Oh, you know what? I apologize. This question, the domain is in degrees. Sorry. So we can just stick with the reference angle being 60 degrees. Okay. So if we know that that's our reference angle, what quadrants are we in? 2 and 3, right? Cosine is negative in 2 and 3. So there's the terminal arm. This is 60 degrees. And here's the other terminal arm. This is 60 degrees. Okay, so that's where the reference angle comes into play. Now we need to figure out the angle from the initial arm. So this is 120. And this one would be 180 plus 60, which is 240. Okay, so the answer to this equation, the solution to this equation, is x equals 120 degrees and 240 degrees. And that's all we can give within that domain. Okay? All right. So now let's look at an equation where we need to give the general solution, and this time we're in radians. Okay? So determine the general solution to 2 cos x minus root 2 equals 0. So we're going to start the same way. Isolate the cosine of x. So if we add root 2 to both sides, we'll have 2 cos x equals root 2. Divide by 2. And we have that the cosine of x equals root 2 over. Okay, so that's a 45-degree angle. Yes, that's the reference angle. But 45 degrees is pi by 4 radians, right? So we want this in radians. The reference angle is pi by 4 radians, which is 45 degrees. Not 450, 45 degrees. Okay, so now I'm going to draw my coordinate plane. Okay, now we want a general solution here. So what I want to know is what 2 quadrants do the principal angles lie in that satisfy this equation? 1 and 4, right? Because that's where cosine's positive, is in 1 and 4. So that's pi by 4. This is pi by 4. Now we need to give the principal angle in terms of a positive angle, or most often that's how it's given. So I'm going to start here and go around the other way, right? And think about going from 0 all the way around would be 2 pi, which is 8 pi by 4. So I'm taking away 1 pi by 4, which is 7 pi by 4. Okay? So my solutions, the general solutions, are that x equals pi by 4 plus or minus 2 pi n, where n is an element of the natural numbers, and x equals 7 pi by 4 plus or minus 2n, where n, 2 pi n. 2 pi n. Where n is an element of the natural numbers. Yes?
Is the 7 times pi divided by 4 just the angle?
Going counterclockwise, yeah. So if you want to think about this terminal angle being here, right? X equals, that would be negative pi by 4. So to get the positive one, I'm just going to add 2 pi. So if we add 2 pi to that, that's negative pi by 4. Now we need a common denominator. This is over 1. So that would be plus 8 pi by 4. And that's where you get the 7 pi by 4. Okay? right, so now we're going to look at restricted domains again. And these are also both in radians. So first let's solve our trig equation. We've got root 3 tan theta plus 1 equals 0. Okay, so I'm going to start by subtracting 1 from both sides. Maybe I'll do that over here. And we've got root 3 tan theta equals negative 1. And then I can divide by root 3. So tan theta equals negative 1 over root 3. Okay. Now, if I'm looking for the reference angle, I want to know what angle has a tan ratio of 1 over root 3. Okay. So if we again think about this triangle, 1 to root 3, 1 over root 3, so that's 30 degrees. Okay, so in degrees, the reference angle is 30 degrees. I think what I'm going to do for these, because I think that that's what you guys are doing, is I'll go into degrees and then we'll go back. Okay? So that reference angle is 30 degrees. Hi.
Do you have the test?
Yeah.
Folder?
I'm just showing Mr. Mark.
I'm just gonna have to plug in the audio again.
Okay. It's up there. Yeah.
Okay.
You're getting caught on video. It's okay, it's just your voice. Okay, so I think what you guys are probably doing is going to degrees, and then we'll go back to radians. So that's what we'll do. Okay, so that's our reference angle. What quadrants would the solutions to this equation be in? 2 and 4, right? Because tan is negative. So if it's in quadrant 2, this over here is 30 degrees. If it's in quadrant 4, this is 30 degrees. Okay, which means that my principal angle starting at the terminal, sorry, the initial arm is 150 degrees. Or if I go all the way around, 330 degrees. Okay. Now, that's not the solution to this equation because we're in the wrong units. So at this point, we have to switch to radians. But it's helpful, I think, to think about this over one rotation. One rotation in radians, 0 to 2 pi. One rotation in degrees is 0 to 360. Okay, so if we multiply this by pi over 180, 15 over 18 is 5 over 6. So this is 5 pi by 6. And again, pi over 180, 33 over 18, 11 over 6. So 11 pi over 6. So those are my two solutions. Okay? Now, if I am doing a different domain, this is like negative 180 degrees, which is less than or equal to theta, which is less than or equal to 360 plus 180. What is that? 540? 540. I'll figure it out. Okay. And in here, oh, there's the headphones. Okay, perfect. Got it. Okay. So we already have these two. We have the 0 to 2 pi. That's these two angles. Okay? So what we need to actually figure out is that's negative pi. Right? We already have the two angles that are between 0 and 2 pi. If you think about this, or even 0 to 360. And then we have to go negative 180 and 540. We have these two. There's 330 and there's 150. Okay. Now, anything where we can add 360 degrees or to subtract 360 degrees from these two, within this number line from negative 180 to 540 will work. Okay, so if I start with 150 and subtract 360, 150 minus 360 is negative 210. So I can't use this one in this part. Okay, if I take 330 though, and I subtract 360 degrees, that's okay. That's negative 30. So that one's good. Okay. Now I can also try and add 360. So if I start with 150 and I add 360, that is what? 150 plus 510? That's okay. But if I start at 330 and add 360, I'm going to be over 540. Okay, so these are the other two that I have to add to my solution, are negative 30 degrees and 510 degrees. But then, of course, I'm looking in radians. Okay, so my full solution would be negative 30. Think about it this way: negative 30 degrees, 150 degrees, 330 degrees, and 540 degrees. But then in radians, negative 30 is negative pi by 6. These ones we've already done, 5 pi by 6 and 11 pi by 6. Whoops. Every time I write 11, I feel like I want to put the pi symbol instead. Okay, 11 pi by 6, and then 540. Okay, so 540 times pi over 180. 540 over 180. 54 over 18. What can we do? So that's, what is that? 17 over 6? 17 pi, thank you. 17 pi over 6. Got to reduce fractions with the denominator of 18. Okay? So there are all of the solutions within that domain. Now, the general solution, we're going to take these two, which are within 2 pi, the first 2 pi, and then add or subtract multiples of 2 pi. So the general solution would be 5 pi over 6 plus or minus 2 pi n, where n is an element of the natural numbers, or that one, 11 pi over 6 plus or minus 2 pi n, where n is an element of the natural numbers. Okay? All right. Solve the equation. Sine x equals negative 4 over 7 over the domain 0 less than x less than 2 pi. Okay, so those are exclusive. To the nearest tenth of a radian using a graphical method. Now, one hint that you may have to solve this graphically is that 4 over 7 is not a trig ratio from the special triangles. Okay, so here's what we're going to do. We're going to pull out our calculators. Now, make sure that your units, or your mode rather, agrees with the units in the domain. So we need to make sure that we are in radians. And this is the same as graphing any other, or solving any other equation using graphing. We're going to make y1 equals the left side, and y2 equals the right side. And I'm actually going to show you, if you're showing your work when solving graphically, the expectation is that you're showing the reader everything that you've done to get to your solution. Okay? So we're going to make a little sketch there too. All right, so the first thing I'm going to do is make sure that I am in radians, and I am. And what I'll do now is graph y1 equals sine x, and y2 equals negative 4 over 7. Now, before you hit graph, go to Zoom. There is a built-in setting for trig, and on the TIs, when you're in the radian mode, that setting goes from negative 360 to 360. Oh, maybe it's It might, yeah, negative 360 to 360, or negative 2 pi to 2 pi. I think on the Casios, it's like negative 3 pi to 3 pi. It adds a little bit extra, but it's the same sort of idea. And then the y values will go from negative 4 to 4. So I'm going to hit that setting, and that's what we see. Okay, now we're going to talk a lot more about this function, y equals sine x and y equals cosine x tomorrow. But one thing I will say about it, because you guys have already sort of noticed it looks like a wave, is that this is called a periodic function or a cyclical function, because there's a specific chunk of it, there's a period of it, right, from here to here, that keeps repeating and repeating and repeating and repeating. Yes? I did zoom 7. Now, this is actually, sorry, the TI, for mine anyway, I know it's going from negative 3 pi to 3 pi. So, but whatever, it'll be on a setting that kind of makes sense, okay? Now, what I'm going to do though, actually, is I'm going to play around with my window settings a little bit, because I know that I only want to solve the equation over a specific domain. And so I might see, like right now in this picture, I see 1, 2, 3, 4, 5 different intersection points, maybe even 6. I'd have to look at that one a little bit more closely. And I don't want to be thrown off. And so I'm going to go into my window and manually make this 0 and this 2 pi. Okay. And then I'll hit graph. And now I know, okay, these two intersection points are the solutions to my equation. Okay? So I'm going to do a little sketch of that. Hey, there's my sketch. Yeah.
For the you changed the domain for the last time.
Mm-hmm.
You just look at the positive x. That's like 0.
So the positive x on the standard setting, and honestly, I can't always remember what the standard is for each calculator, but I was wrong. The standard is actually from negative 3 pi to 3 pi. And it's possible that, I'm curious actually, as to if I used like an older version of the calculator, if it would be negative 2 pi to 2 pi, because that's what I always remember, and I've had this calculator for over 20 years. But the newer ones, it seems like each calculator will do something a little different, right? So as long as you know where 2 pi ends on the graph, you don't have to change your window settings. You just want to make sure not to get extra solutions, okay? So I'm going to go second calc 5. And one solution is 3.75. And another solution is 5.67. Oh, it is? Okay, I think this is actually 3.7 then, because wasn't this 3.749 or something? Okay, yeah, so this is 3.7, and this one would be 5.7. Okay, now this actually makes sense if you think about quadrants, because if you put your radians into decimal values, this is 0, so this is pi, that's 3.14. This is half of that. That's 1.57, approximately. What's 3 pi over 2? I don't know. What is it? 3 pi over 2. 4.71. Okay, thanks. Okay. Now, this sine ratio is negative, right? So if you think about cast, the solution should be in quadrants 3 and 4. And that's exactly what we see. 3.7 is between 3.14 and 4.71. And then 5.7 is between, this is 6.28. 2 pi is 6.28. 5.7 is in here. Okay? So it sort of agrees with what we've already done. And this could be a question that I could ask you to solve without graphing. And then you'd have to get the reference angle. These two angles have the same reference angle. And use your knowledge of cast to be able to figure out the third quadrant angle and the fourth quadrant angle. Okay. Questions so far? Yes?
So what is the reference angle of that?
The reference angle? The reference angle here is going to be sine inverse of the positive trig ratio. 4/7. I don't know. It's what's the difference between 3.14 and 3.7? Whatever this, it's about 0.6-ish. This is about 0.6. And this is also about 0.6, right? 6.3 minus 0.6 is 5.7. Yeah. So this is about 0.6. Yeah. Okay, so now let's get into the actual fun stuff. Okay, so solving a second degree trig equation. Okay, so a second degree trig equation is sort of parallel to solving a quadratic equation in that you are going to see something squared. In this case, it's going to be a trig ratio squared. But the way to solve it is the same as solving quadratic, in that you have to equate one side to 0. And then either factor or use the quadratic formula to get the solutions. Okay, now, there is something that you guys need to know about the notation for when you square or cube or raise any trig ratio to an exponent. And that is, if you have something like this. Okay, let's say I do sine theta times sine theta. Okay, that would be quadratic, because I'm taking a trig ratio, multiplying it by itself, like degree 2, right? We could write this as sine theta squared. Okay, so far so good. Okay, now here's where the new part comes in. The way that we notate this is sine squared theta. So you need to know that those two things mean the same thing. Now, I've never understood why we do this. And I looked it up again today, and the only thing that came up is that it's notation that's given by definition. That's it, right? But it just, it is what it is. You need to know that this means that. And that's sort of the thinking that I go along with most of the time, is that I see this and I think that. Because that looks more like an x squared. Whereas this, it kind of looks like sine's not squared, but theta is. I don't know. Okay? So you need to know that. Same with, let's say you did this. Cos theta cubed. Cos theta times cos theta times cos theta. The way that that is notated is cos cubed theta. Okay? Now, personally, when I'm working with these trig ratios, whether I'm solving trig equations like what we're going to do, which is going to involve factoring, or next semester, if you keep going, you'll look at things like derivatives or antiderivatives of these things, is I always think this way. Because in terms of what we're going to do with it, it makes more sense. So I can't give you a good answer as to why we notate the higher degree trig ratios this way, but you need to know what that means. If you'd prefer to rewrite it like this, by all means, go ahead. Okay? All right. So, yeah, I have that over here. This should not say solve. Oh, yeah, solve the following. Okay, so let's talk about solving these degree trig equations. Okay, you really want to think of it like solving a polynomial equation, specifically a quadratic equation. If we were to solve this equation, x squared minus x equals 0, we would factor. We can factor out a GCF of x. Okay, and then from the factor of x, we get the solution that x equals 0. And from the factor of x minus 1, we get the solution that x equals 1. Okay. Here's sort of a parallel trig equation. Cos squared theta minus cos theta equals 0. So what I'm going to do is I'm going to rewrite this as cos theta squared minus cos theta equals 0. Okay. Now these two terms have a greatest common factor of cosine of theta. So I'm going to take that out. If I factor out cosine theta, from this term, I'm left with one factor of cosine theta. Okay. And from this term, I'm just left with 1. Okay, so where I'm going to go next is from this factor, if cos theta times cos theta minus 1 equals 0, the only way for that to happen is if one or the other factors is 0. So here I can say, okay, cosine theta equals 0. Or here, cosine theta equals 1. Okay, now here's where I have to take the extra step compared to the quadratic. This is not quite solved yet because what I want to know is what angle has a cosine of 0. Let's just work with degrees for now. 90, yeah. 90 or 270, right? Because cosine is the x coordinate. So 0, 1, 0, negative 1. So here the solution is that theta equals 90 degrees or 270 degrees. Now when is cosine theta equal to 1? Yes, because it's the x coordinate. So this guy has the solution theta equals 0 degrees. Okay, so there are 3 solutions to this equation. Theta equals 0 degrees, 90 degrees, or 270 degrees. And just for simplicity, let's assume we're just going from 0 to 360. We'll just do one revolution. Okay. Now, what we're going to do next is just practice factoring. And then we'll start to solve more trig equations. Okay. So there's no equation here. There's nothing that equates to 0. We can't actually solve this for anything. But all we're going to do in this step is just practice the factoring piece. Okay. So when I look at these two terms, is there a common factor? Yes, sine of x. So I'm going to take out a sine x. And from this term, what's left? 1. Yes, and from this term, 2 cosine x. Okay, so that's how that would factor. Okay, tan squared theta minus 9. So when I see something like this, eventually you'll be able to just see, okay, that's like tan theta squared. And you may even be there right now, but if you want to rewrite it as this, okay, no common factor there, but can we factor it? Yeah, it's a difference of squares, right? So tan theta plus 3 times tan theta minus 3. Okay. And then finally, secant squared theta minus secant theta minus 12. So you may even want to do that so that you can almost say this is like the x, right? It's like x squared minus x minus 12. Yes?
For question A,
Uh-huh.
sin x, would you factoring out 1 sin x?
Okay, good question. What this term means is 2 times sine x times cosine x. So what I did was I took the factor of sine x out, but these two factors are still remaining. Yeah? Okay. All right, so this is similar to factoring the quadratic x squared minus x minus 12, right? Think of it that way. So you need to think about two numbers that multiply to negative 12 and add to negative 1. Yeah, negative 4 and 3, right? So this guy, I should have given myself more space, but I'll write it above. This guy is x plus 3 times x minus 4, right? So this one is going to be, instead of x, secant theta plus 3 times secant theta minus 4. Okay. Now let's get to the good stuff. So we're going to solve this equation over 0 to 2 pi in radians, and then we'll give the general solution as well. Okay? Now, when you are solving a trig equation, because I'm not going to say to you, this is a simple trig equation that's degree 1, and this other one is another trig equation that's degree 2. I'm just going to say solve, right? So what you want to look for, because if it's sort of degree 1, it's like solving a linear equation. So the process is different. You collect your variable terms on one side and your numbers on the other, and then you can divide by that coefficient. If it's quadratic, you need to make one side 0. So one thing that I look out for, first, if you see something like tan squared theta, that's a giveaway. But I also look to see, am I ever multiplying two trig ratios together, right? And that's what I see here, sine x times tan x. So these each have degree 1. If I multiply them together, it's degree 2. So this is kind of like solving a quadratic equation. And what that means is that I need to equate one side to 0. So I'm going to subtract 2 tan x from both sides. Okay. And now what can I do? Yeah. Factor out a tan x. And here I'm going to be left with sine x. And here I'm going to be left with minus 2. Okay? So actually, let's start with this one. If sine x minus 2 equals 0, what does sine x equal? 2. Try doing that in your calculator. Sine inverse of 2. Yeah, error. Okay, now why is that an error? It's an error because sine is opposite over hypotenuse. The opposite is always smaller than the hypotenuse. Always. Unless if the angle is 90 degrees, then they're equal to one another. So the max that ratio can be is 1. Same with cosine. The max that cosine can be is also 1 because the adjacent is always smaller than the hypotenuse. The hypotenuse is the longest side. And so anytime you have sine or cosine equal to, or the cosine of an angle equal to a number that's larger than 1, there's no solution. Okay? You're like, yes, I don't have to do that one. Yeah, so this has no solution. No, we're just not going to get a solution from that part. It's still defined, right? It's like saying if you have a quadratic that doesn't cross the x-axis, it's above the x-axis or below, it's still sort of defined, but there's no solution to that. Okay, now this guy, though, tan x equals 0. What would the solution to that be? That's 1. There's another one, though. Pi, it's 0, 2 pi.
Oh, no.
No, hold on a sec. Where is, it's the, okay, never mind. You're right, it's 0 and 2 pi. I'm overthinking this. Yeah, so you could either do this. So it would be 0 over 1, that's 0. Okay. Or 2 pi, because those are the same angle. I was overthinking it though, but because I'm thinking of tan x in terms of sine x over cosine x. So I'm like, okay, tan x is going to be 0 wherever sine x is 0 because they're both in the, sine x is in the numerator. Yeah. Yeah. Okay, so pi, no, you're right, yeah. It's the y coordinate, yeah, it is. Yeah, that's, I wasn't overthinking it. Pi as well. Because, okay, tan x equals y over x, or sine x, sine theta. Oh, sorry, I should use theta because I have too many x's. Over cosine theta. So where would this be equal to 0? Wherever y is equal to 0. Right? So y is equal to 0 here and here. That's 0, pi, and then 2 pi. Yeah. I got to go back to the base. That's my problem. Doing too much in my head. I got to rely more on my special triangles and on points on the unit circle. Okay. All right, now the general solution. Okay, so let's think about this. If x equals 0, pi, or 2 pi, what's the general solution to that? Okay, so x equals 0 plus or minus 2 pi n. Okay, what else? Right. Okay. Now, could you write this as a single solution instead of with 2? Okay, what would it be if you wrote it with as one equation, one general solution? This one's going to be 0 pi, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, etc., right? Not, so we're doing two pieces, domain and then general. Yeah. Okay, so look, think about this one. Okay. This is 0, 2 pi, 4 pi, 6 pi, 8 pi, etc., right? This guy is pi, 1 pi, 3 pi, 5 pi, 7 pi, etc. Can you put those together? Okay. So what would the solution be? 0 plus or minus? Right. Pi n. N means that you're adding multiples of pi. N has to be a natural number. So you can't add like half a pi. That's not going to work. You have to add full multiples of pi. Okay? Now the reason why I bring this up is that if this was a multiple choice question, this would be the answer. It would be combined into one. Okay? Yeah. All right. give exact solutions where possible. Otherwise, give approximate measures to the nearest with an n, thousandth of a degree. Here's thousandth of a degree. Okay? All right, so we have this equation, cos squared theta minus 1 equals 0. And our domain is 0 to 360 degrees. Okay, where would you start? Okay. Isolate cosine.
Oh, wait.
It's quadratic, yeah. Right? So what are we going to do? What's that? Factor, yeah. This is a difference of squares, right? Think of it as cos x squared minus 1 equals 0. So these are both perfect squares.